Welcome to the Future Ventures podcast. Today's conversation tackles one of the hardest problems in the energy transition, not how we generate electricity, but how we replace coal in heavy industry. I'm joined today by Ivar Skårset from ENEnergy, a company focused on renewable fluids and next generation fuel alternatives designed to displace fossil inputs in industrial systems. This isn't about theory or long-term climate targets. It's about what actually works inside boilers, kilns, and industrial processes today, and how you transition without shutting down these systems. In this episode, we're going to unpack what it really takes to replace coal at scale and why most people underestimate how hard that is. Welcome to the stage, Ivar. I'm super excited to connect with you today and talk about ENEnergy and what you guys are building.
Thank you very much for having me.
It is my absolute pleasure. Why don't you tell us kind of like your origin story and how did you come to found ENEnergy?
Yeah, that's actually we actually founded the company about 20 years ago. So we have worked on this for quite a while now, and it was a guy that I was working together with. Excuse me. At that time, it was around the time when it really got obvious that the fossil fuels were letting out a lot of CO2, and that remained in the atmosphere and started to alter the climate. So we started to talk a little around that topic, both of us coming from the oil business. So we were thinking, what can we try and do to replace these fossil fuels with similar renewables ones, because we thought that would be the most efficient way to cope with the emittance of CO2 and other greenhouse gases. So then we started to develop from there, and we found that producing fluids like gasoline replacement and diesel replacement, and not at least SAF, could be done in large scale. And so we thought we would take on that task and see what we could do about that. And we found also that it would be possible to produce stuff called lignin, which is actually the material that keeps trees and bushes and whatever other plants standing up and not falling apart. So it's quite a strong material, and it has sort of the energy content like coal, so it's a good replacement for coal, as you said in your introduction, in industrial use. So yeah.
Well, what I was going to say, I mean, a lot of those systems are built in. So how easy it is to replace what currently exists with what you are working on?
You mean, for instance, in engines and cars, right, and stuff like that? If you take an ordinary gasoline motor or an Otto motor, as its original name is, the first ones were actually built for alcohol as the energy
input source.
Yeah. So it's not the problem to run an ordinary gasoline motor on alcohol on 96%, so to say. But the things you need to do differently when constructing the engine is some gaskets and small pipes need to be in material that can tolerate the alcohol, because alcohol has a tendency to dry out materials that it's in contact with. So and that will mean minor changes actually to the engines, so that you could rebuild an existing engine to use 100% or 90% alcohol and and 10% gasoline, for instance, or just go on alcohol with relatively small costs. Instead of buying a whole new vehicle like an electric car, for instance.
Understood. And what is the best primary use for the fuels that you're developing using this renewable biomass source, as well as, does it pack the same energy density as like traditional fossil fuels?
Does it? I didn't hear the question. Yeah.
Does it pack the same energy density as traditional fossil fuels?
No, it's a little lower on the energy density.
Okay.
So you're spending the alcohol or the renewable fuel a little faster, but you actually also get more horsepower out of it.
Okay.
And that's a strange situation. So you can actually compensate the lack of or the less energy density with using a smaller engine and still get the same horsepower out of it without losing any energy density, so to say.
What are the critics saying? Like, why? Like, in terms of adopting this as a solution, like what are their biggest objections?
What I have sort of thought in my mind, I think when we started out about 20 years ago, producing these renewable fluids were quite popular for a while. But people started to use agricultural land areas and also actually agricultural products to instead of feeding it to people, started to produce
sustainable aviation fuel.
And that was obviously not a very good idea. And I think that has actually given renewable fluids from biomass a bad reputation. And then came this electricity and electrification plans instead. And they have actually done a lot of erections of, wind turbines and sun power plants, and the whole renewable business to cope with the emissions have been turned to electricity.
I mean, Ivar, you and I have had numerous conversations, but can we step back and just kind of explain what ENEnergy is and how it works? And so maybe give us the pitch as a, like, from a to non-technical people, kind of like, what does it mean? How does it work? We're talking about like using semi-arid or arid land to grow the biomass. Just let's step back and just gonna provide an overview of ENEnergy and the solution.
Sure. Yeah, the company name is ENEnergy, but it is of course about producing renewable fluids and renewable coal replacement. That's the whole business. And as you say, we are planning to do this on arid land, barren land, and it's a lot of that in Australia, where our primary, which is our primary area or country for
especially the northern part of the continent.
The northern part, what they call the top end of Australia, is very well suited for this. because the the land areas there are either barren or it's large. There are a lot of large cattle stations, and the cattle sort of, I think, suffers a little from grass that doesn't get enough water and stuff like that. So it would be actually a win-win situation we have found, because we can irrigate. We plan to irrigate. It's part of the process.
Can you tell us how you plan to irrigate? Because that's an important distinction.
Yeah, yeah, it is. We're planning to irrigate with saline water and desalinate it somewhat, not full extent, but the plants we're planning to use, they will be able to thrive on saline water, partly saline water. And we will also then be able to provide water for the areas where the cows can be fed, and these areas will then be smaller because the grass will be of better quality and they don't need to be that large. So we can use then the rest of the land for our purposes and grow energy-rich plants, fast-growing energy-rich plants without sort of making any problems for the food production. Since the food production there is milk from the cows until they are slaughtered and provide meat instead.
So what happens with the partially desalinated water once it enters in the soil?
The salt will sort of at least partly be a nutrient for the soil, but so we don't think that will be a big problem actually.
Okay.
And if it is, we can of course desalinate totally.
More.
Yeah.
And so from a cost perspective, how does this compare to a traditional fossil fuel that's being mined or extracted from the ground and then converted into its finished products?
Yeah, we can do this much cheaper than an ordinary fossil oil production or oil field. Maybe not those who exist now on land, like in Iran, Saudi Arabia, and some of these places, but I think very many of the newfound oil fields, they are below the sea bottom, and then it gets much more complicated, of course, and much more expensive to extract. So we will be able to compete with the oil products, absolutely. And we will also be we can also receive CO2 certificates, of course.
In terms of sequestering carbon?
Yeah.
Okay.
Maybe we'll come into that later, I don't know.
I mean, this is a good point to explore. So tell us a little bit more about the carbon sequestration. How are you planning to market the carbon credits? What does this mean from an economics perspective as well?
Yeah, when the plants grow, they need CO2 actually that's their nutrition, and so the plants, all plants on Earth, they extract CO2 from the atmosphere and use that for their own growing purposes, and they emit oxygen as a sort of a waste product from the plants. That's the photosynthesis in very short.
Yeah.
And together with our products replacing fossil fuels, so that they will be hindered in entering the atmosphere. This will actually make us CO2 negative, so that we are actually, our products are emitting less CO2 to the atmosphere than we extract from it.
Yeah.
So, and this will give us, as you say, carbon credits. And if we add on carbon credits as at today's price levels, I know there's several different prices existing, but if we go on even if we go on the lower side of this costs, we can actually go price negative if we like.
And is Australia still the best candidate in terms of, or the best beachhead market for you to enter and build this?
If again, I didn't hear exactly what you said. I'm sorry.
Is Australia still the best market for you to enter?
The market, I think, will be to begin with. Of course, we will not produce very large quantities of this, but after when we have expanded this business, because of course we plan to expand it so that it will be great, maybe replacing all fossil fuels when we come to the end of it, but that will probably be after my time. It will take some years, but that is our plan, actually, is to be able to replace all fossil fuels with renewables. And then, of course, the market will be as the market is today. So we will be reliant on tankers to transport it, and like it's transported and distributed today, actually. So we'll use the same chains.
So if we're thinking about the different fossil fuels, kind of like what is the best, what fuel is it best positioned to replace? Is it coal? Is it sustainable aviation fuel? You talked about lignin, kind of like where is it best suited?
Yeah, that's an interesting question. I think the products that we most easily can produce, those are the gasoline replacement in terms of and lignin, those two. But I think what will be or at least as is today, I think the most wanted product is the SAF, because since one focus a lot of electricity on the automotive part still.
Yes.
But so SAF and lignin, I think, and gasoline will be the products that because we can produce SAF from alcohol as a starting point, but it needs to be processed further.
So if you were to juxtapose ENEnergy and the solution that it has versus renewable energy, because the energy transition has started long ago, and we're very much in the process. So are you able to compare the renewable biomass fuel sources that you're creating versus, let's say, a renewable energy being used to electrify the grid or generate electricity, which this electricity is then converted into, like, I don't know, in the case, let's say an EV, electrical vehicle, versus a traditional ICE engine car using the renewable fuel that you're producing versus an EV car using renewable energy?
how I would see that, or how I would compare those two.
Yes.
Yeah, I would say that it's much easier to convert a car with a combustion engine. It's much easier to convert that to be able to run on 100% renewable fluids than it is to construct a whole new application like an electric vehicle. And I think that's also that's natural, and in a way you can see that it's we have had the electrical vehicles for about 20 years now, I think, as well, and quite a few of the vehicles on Earth has been replaced with electrical vehicles over those 20 years. I think it's about 1 million or 2 maybe electric vehicles, and 1 billion, no, 2.5 and maybe 3 billion vehicles in total. So it's quite a small part of all the vehicles being electrified so far. And we are perhaps running late on doing the conversion to renewable energy sources. So, and I think electrification will take time, not just to help, so to say, renew all the cars from combustion engines to electrical, because that will take a long time, but also to do all the grid work that needs to be done. It's a tremendous task. I mean, today electricity is about 20% of the total energy consumption in the world. And you want to sort of 5-doubling that to get all the energy
being consumed.
Electric. And I think that's an impossible task. And another thing is that today about 60 to 70% at least of the energy carriers used are fossil, also into the electricity production. So it's because it's coal and gas, they are producing a lot of the electricity that we use.
Understood. I mean, given the natural advantage of not having to build new infrastructure and just using the existing infrastructure, maybe with minor modification, what else gives you an edge over incumbents or alternative solutions?
I think that are two strong reasons.
Value props,
but it's also, I think, of course, the fact that we are CO2 negative in our process from we start growing the raw material until it's combusted and back in the air again, so to say. We are CO2 negative, and that's needed since I think it's quite a few years ago since the scientists in FPCC they said that it's the saturation is reached. So to get some of that back and down in the earth again would be a good thing, I think.
How quickly does industry need to adopt this as a solution before to drive a meaningful impact or contribution in terms of like decarbonization?
Yeah, I think it will take, from we have done maybe a little optimistic calculation on that, but I don't think that we will be able to get really into the decarbonation in terms of extracting more than we emit on the globe as such, it will take 15-20 years, I think.
Mm-hmm. So electrification gets all of the headlines at the moment, but is it realistic for heavy industry in the near term
to
electrify heavy industries versus like using the kind of the traditional the renewable sources that you're building?
I think if you take, for instance, steel production,
Yes.
they are totally they cannot do their job without coal, because coal is a part of the steel. The steel is sort of a combination of coal and iron. So you need the carbon to from the coal to actually be able to produce steel, and that you also can do with lignin. But lignin is it consists also of other stuffs than carbon. It's also hydrogen in the lignin. You have to take out, but it can be done. It can be used in the coal production instead of in the steel production instead of coal. So, but when it comes to other heating purposes, like if you have a coal electricity plant, a coal-based electricity plant, you can modify that coal burner to lignin quite easily, and then you would have a coal-fired electricity plant that is renewable instead of using the worst of the fossil fuels to produce the electricity.
So many coal-fired power plants in the developed countries have been shut down or mothballed. The two obvious questions that come to mind for me would be like, what would it take to restart them, and can you produce a stable supply of fuel source for those plants to operate?
Yeah, you can.
Okay.
But of course, you need to you need to produce a lot of it, and you need to build a lot of sites for producing or for our production system and concept. To replace coal in all the coal-fired electricity plants that exist on Earth. That will be, I think you need to think long term to do that. But as you say, they are shut down. A lot of them now are shut down, and I'm not an expert on this exactly, but I don't think they can be shut down for too long before you start trying to restart them. And at least they need to be maintained to a certain degree during this time to be able to do that without actually risking some accidents and stuff like that, which you want to avoid.
So a lot of coal-fired power plants are located naturally close to coal sources to reduce the cost of transportation or getting the coal to the power plants. If the best location for your solution is arid or semi-arid places, barren land, How does this fit into the grid?
Could be tempting to say not at all,
Okay.
because you're right. We're going to be placed in remote areas where there is not a lot of infrastructure. But one thing that we require is to stay close to a port, and
Okay.
we will pipe our products to be stored on land or on site in the port, and so that it can be shipped out from there. And when it comes to coal, at least in Australia, a lot of it goes on railway. So we would of course be able to pipe the lignin to an area or a site where it can be loaded on a railway. So, but again, when we start to really when the amount of products that we can deliver will increase, and we will probably also be other places than in Australia, and it will not be ENEnergy doing all of this. Of course, it will be many companies involved in this. The way we see it, we think we will have to try and build a series of plants and with plantations around the world, and having many companies involved in this, like there are many oil companies that produce oil from different oil fields. We will have these oil fields on land instead, more accessible. It'll be on top of the land too. Everyone can see it, and much easier to operate in that sense.
Understood. What are the industries that are most ready for the transition, and which are the hardest?
I think that at least what we have been thinking will be the not the easiest, but maybe most efficient way for us to start is to produce gasoline replacement, and as I said, lignin. Because these can go directly into existing cars and also existing industry.
And the gasoline would be the same? Would there be any modification required to the engines? You mentioned that alcohol has the tendency to dry out certain parts, or you're mentioning gaskets. Is the product you're producing closer to LPG, like liquefied petroleum, or is it like same in essence as traditional gasoline?
Yeah, I would say it's more like traditional gasoline.
Okay.
So it works at ordinary temperatures, for instance.
Okay.
Yeah, so it's more like gasoline.
Okay.
Then one of the problems is that it sort of, if you can produce 100% alcohol, but when you expose it to the air, automatically it's reduced to 96% because it extracts water. That's one of the problems, and that's also it takes out water from these gaskets and from rubber pipes and things like that in the engines. So you have to, but it's relatively small operations, I think, to modify. I haven't been, I'm not an expert on that, but what I've heard is that it's not a very big operation to do it. It's not as big as building a whole new car with a whole completely different set of energy carrier system.
So this is capital intensive to start and operationally complex. Is this the biggest challenge standing in your way?
What?
The capital required to build out the initial plants and plantations.
The capital required, you say? What has been our biggest effort actually over the last years is to find the money that we need to prepare all the evidence that this is possible to do. To do all the documentation that we need to have others helping us out to do. That capital requirement is very hard to fulfill. But we have a lot of interest in constructing the plant and doing that part of the work, and also the financing of it. But to get to where we can start planning for the construction, that's the hard part to get financed.
I mean, Ivar, you're based out of Norway, and Norway is highly regarded as one of the wealthiest countries in the world because they created the sovereign wealth fund using the proceeds from fossil fuels. What has been the reaction within Norway when you're pitching them an energy?
It's sad to say, but the interest is very low.
Interesting.
Yeah, it is, but I think it's connected to the oil business. Is very is profitable, and it's still a need for these fossil fuels. We cannot live without them. I think you can see that, especially now when things are going on in the Strait of Hormuz, and I think it's 20% or something of the oil that comes through there, and
comes out through the strait.
Yeah, and the panic is is on a certain level due to these 20% of it all. So we really need the fossil industry still. We cannot replace it with electricity. That's going too slow, and other sources does not yet exist. But hopefully we will be able to do something about that soon. But I think the oil company in Norway, like both Shell and British Petroleum, also had tried. They're into their interest in renewables is wind turbines and wind turbines at sea. That's what they're interested in. It's very expensive, and it's I think quite difficult to deploy, and it's not like an oil platform. It's very different from that. So, but that's what they're focusing on when it comes to renewables. So they're not interested in renewables to replace their main products.
But many of the majors and super majors have they have sustainability reports, they have ESG functions, they have stated targets around drive to net zero. Renewable, like wind power by itself, is not going to drive that much of a significant reduction in carbon emissions, or so. I'm surprised that Equinor or BP or Shell is not jumping on this and saying, "Hey, can we evaluate it?" And so I've worked for many energy companies, and so the typical process is like you have an idea, you develop to a point where you present to like some form of an investment committee to decide what it's worth allocating capital to this idea, and obviously. The capital flows to the opportunities with the highest expected rate of return. So, what would like from, if you're putting yourself in the shoes of an executive within an energy company, what would the development of a solution using your methodology and framework cost or compare, or what is the rate of return vis-a-vis pursuing other sources? And I mean, every oil and gas company or energy company has like a multitude of different solutions. From like, obviously, we start with the easy to extract conventional, like the in situ. There's the mining. There's like, but then there's the power generation using different sources. Kind of, how would it compare? Where would it stack or rank? And what is the expected rate of return, along with the risk? Because risk is obviously a key component to this.
Yeah, it is, of course, we are aware of that. There are risks involved, but when it comes to oil companies, it is very interesting, as you said couple of minutes ago, because we have been in contact with some of them, but at first it's very difficult to get in contact with them. They're hard to find, so to say, hard to get to. But when we have managed a couple of times, we have been able to get in contact with the upstream people doing the upstream part of the oil business.
Yeah.
And they're embracing it. They're saying, yes, this is what we need to do. This is the future, sort of. And this is really the thing.
Okay.
Yeah. And then they say, but you need to go to our renewable department, because they're the ones who deal with the renewables.
Makes sense.
The fossil. And then it's the lid is put on.
What about working with?
That has happened more than once.
Understood. What about working with global accelerators like Techstars? Techstars is partnered with Equinor, and they run this cohort-based programming. Obviously, from an Equinor, from a corporate VC sponsor perspective, their goal is to produce and supply energy, and so there's the traditional fossil fuels, but they're also looking for alternative solutions. So, have you tried that way?
I didn't know actually about that cooperation they had with Techstar. Was that what you just said?
Techstars is the second largest accelerator in the world after Y Combinator, and so a lot of companies would. I think Techstars Equinor is based out of Oslo. I'm not sure. Absolutely. So even a lot of Canadian companies would go there, prove out solution. A lot of the European companies are a lot more supportive of experimenting with different ideas and solutions, and then prove the solution there, bring it back to North America. One example is a company called Crux OCM that did exactly this. Canadian company. Two founders came from TC Energy and Enbridge. Piloted the company with Techstars Equinor. built it out, and then came back to Canada and in the US. So just an idea. David Cohen is the CEO of Techstars, and they run global accelerators all over the world. I think the most recent two are Sarajevo and Istanbul, but like the one in Norway is sponsored by Equinor.
Okay.
Yeah.
I will follow that lead. Thanks a lot.
For sure. For sure. Any parting thoughts? I know we're coming on at time, Ivar. Any parting thoughts? How should people get in touch with you if this has piqued people's interest? What should they do?
To get in contact with me, they can write to me in an email. That's the easiest way, I think. And that is you want you have my address. It's IS and the at ENEnergy.net. That's my address.
Amazing. Well, thank you so much for your time. Thank you so much for sharing your insights and in terms of what you're building and how you're thinking about the replacement of traditional fossil fuels and how this could lead to the energy transition.
Thank you very much for having me again.
My pleasure.